Today's tutorial is about MOPs Edit and MOPs Physics Edit. These tools are designed to quickly and easily tweak the transforms of packed primitives, similar to the way the edit SOP works with regular geometry. MOPs Edit is the simpler of the two nodes. You can quickly grab and adjust the transforms or pivots of any packed primitive for set dressing or for tweaking the results of an animation or simulation. You can also use a special duplicate mode to make in-place copies of your selection and quickly reposition them. This is especially useful for layout. MOPs Physics Edit is a bit like enabling physics in LOPs, but this is all in SOPs. It uses a quasi-static bullet solver to resolve collisions between objects while you drag them around. This can be really helpful for quickly making piles or messy layouts that have a more natural arrangement of objects than you would with a typical scatter. We'll start this tutorial by taking a look at MOPs Edit and then move on to the slightly more complicated MOPs Physics Edit. They're both pretty easy to use once you get the hang of them, though. Okay, so we're going to start with the simpler of the two nodes, MOPs Edit. I've got my testing here that's just a Paul geometry, a MOPs instancer to make a bunch of clones out of them, and then the MOPs Edit node. One of the things about the instancer that you'll want to pay attention to is that it does create an ID attribute. Now, you don't need to use MOPs nodes to generate packed primitives. You can just use a copy to point SOP, but for MOPs Edit to work, you do need an ID attribute present, so just keep that in mind. If you're not using MOPs, you can always use, for example, the enumerate SOP to create an ID. Just set this to points and then set this to ID. And now you've got an ID. Or you can just do a point wrangle. Just say I at ID equals at ptnum, and now you've got an ID attribute. That's enough to make this work with MOPs Edit. Okay, so onto the node. When you click on it, you'll notice that there's not a whole lot of parameters, and there's nothing happening with geometry, and that's because you're expected to use the node handle to do basically everything in this node. To activate that, you can either click this button over here on the left to enter the node state, or you can just, with MOPs Edit selected, point to the viewport and hit enter. And now you're going to get this little hint up here, and you're going to get a selection handle that allows you to select any of these primitives. Once you select something, you're going to see a handle appear, and now you can just use this to manipulate the packed primitive. So I can drag this guy around here, I can drag this one. You can just like keep selecting and moving things, and all of these edits will happen cumulatively. So I can grab this guy, maybe rotate him this way, move him forward. Now, one thing you'll notice is that, let's say I grab this guy, and I've already made some changes to him, but if I turn off local space, you can see that the handle immediately shifts so that Z is facing world Z, X is facing world X, and so on. This handle you can also toggle by pushing the M key in the viewport. So that just quickly toggles that on and off. This is especially important to pay attention to if you have multiple Pauls here that you've got selected. So like, let's say I select all of these guys here. If I'm in local space mode, even though the handle is pointing this way, the handle is only pointing this way because it's aligned to the latest Paul that I've selected, sort of the last one in the group. But if I pull forward in Z, you're going to see that these guys over here on the right are moving in their own local Z space. So they're going to move forward. If you don't want that to happen, hit M or hit select local space, and then when you move in Z, they're all going to move in world space. Deselect, hit M again, or just click local space here because I like that. And so again, you can move these guys around, you can rotate them. Notice that unlike the edit SOP, these guys are rotating from their pivot points. The pivot, when Paul is packed here, is between his feet. If you're using the edit SOP, this pivot would be in the packed primitive centroid, which is often not what you want. It's often what you want, but if you've gone through the effort of defining a custom pivot for these guys, you want to make sure that he's rotating around that. For example, if I want him to lean forward, I want him to lean forward and stay on his toes. So that's something that MOPs Edit does that the default edit SOP won't do for you. When I have all these Pauls where I want them, I can hit escape, and that commits the tool state. So now if I go back up here, and then go back to MOPs Edit, you can see that these changes are committed. So the edits are basically destructive when you think about how the edit SOP works. You're expected to have an input state that's usually static. Typically things aren't animating going to this, although it is possible to edit animated geometry. And the output is basically just fixed here. But something to note about this SOP is that it is technically not destructive. It's recording all of the edits that you make and then storing them in a multi-parm. And if you want to see what those edits look like, you can click Show Edit History right here. And this is actually going to show you in this multi-parm block a list of every edit that you've made. And so here's in order every change that I've made. So this last change that I made, I rotated one of these guys. And I can actually go in here and modify this after the fact if I want to. these edits all stay sort of in this stack here. The only downside to this is that if you have a ton of edits, like a ton, while you're doing the edits, mops edit is going to cache the local state. It's going to stash the geometry that you have every time you make a change. So interactivity will remain pretty good while you're actively changing things. But if you have a ton of edits, it might take some time to cook once you've actually committed the state and exited the tool. So keep that in mind. If things start to get a little bit slow, if you've made a lot of edits, it might be a good idea to cache the output just with a standard file cache or with a stash sop, depending on what you prefer for your scene. To re-enter the state, I'm just going to click in the viewport and then hit enter again, and now I've got my selection handle. So another important thing to show here is when you select these things and you get this handle, you can move things using the handle like you'd expect. So I can just move these guys from side to side, but you can also make these adjustments directly in the parameters window. So if I want to move these guys, I can use the value ladder like I normally would to edit things. This includes scaling, but if I want to scale in the viewport, the default handle that you're given here doesn't have scale options. So if you want to you can activate them. You can see up in the corner here this hint that says Y and Shift Y cycles handle. So if I push Y, you can see that it's going to switch between the sort of multi-manipulator to a scale manipulator. So now I can actually adjust scale here. A translate only manipulator, select these guys again, move them around, and then back to this multi-manipulator again. And if I hit Shift Y, it's going to do it the other way around. So good thing to note, especially if you want to be able to scale in the viewport, use Y to make this adjustment, and then you can hit Y again to get back to the multi-manipulator. If you want to undo the last change that you made, you can either go to the edit history and remove it this way, just sort of click here and that'll remove the edit, or I can actually click remove last edit, and that will sort of remove the last edit that was made in the multi-parm and then update the viewport to match. Okay, again, I'm going to hit escape to commit this change, and now this is all locked down. The other button up here, reset all changes, is just going to undo everything that we've done here and revert it back to the way it was before the SOP was dropped down. So if I click reset, this whole thing is cleared. I can just turn off show edit history and everything is back to the way it was before the edit happened. Now there's one parameter we haven't really gone into yet, and that's a very important parameter, the edit type. So far we've just been using the edit type, which just means grab a thing, move it around. But there are other edit types that we can go into. I'm going to activate the tool state. Now, if I change this to duplicate instead of edit, and then grab one of these guys, you're going to see that he leaves behind a clone. And so I can, position this clone, do whatever I need to do, get him where I want him, and then select something else. So maybe I want to select this guy. And you can see that this can be really handy for set dressing. I can just grab multiple guys here, move them where I need them, position them, whatever I need to do, and then go back to edit mode, and then select, and then keep making small changes, and then go back to duplicate later if I need to. So maybe I can adjust this guy, go back to duplicate, grab him, make another copy. Maybe I want that to be in local space instead of world space, move them around. And so you can see how useful this would be for set dressing if you just need a bunch of copies of the same things kind of just scattered around by hand and manually placed this way. So I'm going to change this back to edit. Now if I hit escape, it'll commit the state, and I'm good to go. So you can use this to make additional copies, and just so you can see this, if I go to the spreadsheet and go to the instancer beforehand, you can see that these guys are given all of the same attributes and they're given new IDs. So if I look at the original instancer here, I've got 25 packed primitives, ID 0 through 24. And if I go here, you can see that it's just sort of accumulating IDs as we place these things. And they're also given names. So anything that you create with this node in duplicate mode is automatically going to have all of the same appropriate attributes that'll let you use these with the rest of MOPs or with RBDs or really any other system in Houdini. They're just packed primitives like anything else. And if I go to the edit history, you can see that the edit type is listed as duplicate here. And you could, if you wanted to, change this after the fact, change what primitive you're adjusting, the transforms, whether you're duplicating it or editing it, whatever you want. I don't recommend messing with this too much because if you're relying on a primitive downstream that we've created, that could mess up Houdini pretty badly and confuse it. But you do have the option to change these things after the fact. I'm just going to reset these changes really quick. And the other very important edit type is pivot mode. And you can select it from this dropdown, but the easier way to do it is to actually just activate the tool state. And then you can see there's a hint here to hit the apostrophe key. This is kind of how you would manipulate pivots if you were using the regular transform SOP, which is why it's the same key here. But in this case, what I can do is I'm just going to select this guy, and you can see that it has the regular transform manipulator. But if I hit apostrophe, now this is switched to pivot mode. And let me just zoom in a little bit. And you can see that the pivot is right between his feet here. But I can move it up and then hit apostrophe again to go back into transform mode. And now I can rotate this guy or scale him or do whatever I need to do. And that pivot change is permanent. So if I, let's say I want to move him this way, maybe I want to scale him up. All of this is happening from this new pivot I've defined instead of the pivot that was already there. So let me select this guy, hit apostrophe. I'm going to move the pivot up near his head, hit apostrophe again to exit edit mode, and then maybe I can scale from here, or let's hit Y and then rotate him from here, and you can see this is a new pivot. And now if I exit the state by hitting escape, and let's say I want to apply a MOPs transform after the fact. So I'm going to just hit S to select, grab this guy, and then MOPs transform, just the regular MOPs transform modifier. And now you can see that the handle is at the origin because that's just sort of how MOPs transform modifier works. It doesn't draw handles the way that MOPs edit does. But if I rotate this guy, you can see that it's rotating around this new pivot that I've defined. So that it's kind of working like the MOPs pivot modifier, where it's sliding the point position and the pivot at the same time so that it's kind of invisible. The thing doesn't visibly move when you adjust pivots, but the point position and the pivot intrinsic are both updating, and that's a permanent change. So this is really powerful. While you're doing this set dressing or while you're sliding things around, you can just hit apostrophe, slide the pivot to where you need it, hit apostrophe again, and then keep editing. It's really powerful once you get the hang of it. All right, now we're going to do a slightly more involved example. Let's say that you're doing an RBD simulation here, and you might want to just make some quick edits to a couple of different pieces to get them exactly where you want them. I've done similar demos on this using MOPs transform, but sometimes edit is a little bit easier to mess around with. So let's just show how that workflow might work one more time. I'm starting with a rubber toy and an RBD material fracture, so I'm just breaking this up into RBD chunks. And next up, what I'm going to do is I need to pack these. Now, normally RBD, the built-in solver doesn't require you to pack anymore, even though under the hood it is packing. It's creating packed primitives for you. But here I want to do this manually so that I can make sure that the output of the bullet solver is going to be packed. If I feed in unpacked geometry, it's going to come back out unpacked, and then I'm going to have to assemble it after the fact, and it's just kind of annoying. So let's just pack it in advance. It'll be a lot easier this way. So I'm going to drop down a pack SOP, and I'm going to just transfer the name attribute across. And then I just have to enable name attribute here. And now you can see I have about 80 packed primitives, and so that's one per piece. So before packing, I have all of these as individual faces, and now I have one per chunk here. The next thing I'm going to do is promote that name attribute. I want this to be a point attribute and not a primitive attribute. This is, again, making it behave more like packed RBD used to work before the SOP version of it. So I'm just going to take this from primitive to point. That's the name attribute. And now if I go to my spreadsheet, the name attribute is right here. Now, next, for this simulation, what I'm going to do is just drop it from a short height and then watch it shatter. And I'm just going to show you a little trick here. I have these, let's say I have these constraints all set up, and now I want to actually be able to fine tune the exact starting position of this thing. I don't want to have to just transform it upstream here, because if I do that, now every time I move it, the RBD material fracture is going to evaluate the shatter differently because it's evaluating that in sort of in world space, or at least in the space of this geometry container here. So instead, what I can use is RBD pack. And if I wire in the constraints and the geometry here, what this does is basically pack the entire thing down here into just one little bit. It's basically a separate primitive for the geometry and the constraints and potentially the proxy geometry. And now I can move everything as a whole without actually impacting anything. So the constraints and the pieces are all going to move as just one little object here. So what I can do is, let's say I'll just move it up to, let's say, about 3.5 meters. So it's going to get a little bit of height. And then if I wanted to, I could also just rotate it. So let's just, maybe 38 degrees in X. And so now it's going to impact at an angle here. And I'm doing this and it's not having to recalculate anything. So that's really useful if you know that you're going to need to fine tune something like this. And then as soon as I'm done with that and I want to put this into a simulation, I can just do RBD unpack. Now everything's back exactly the way it was. I've got my chunks here, and then I've got my constraint geometry. Everything's already in place relative to where it already was. Now it's time for the bullet solver. I'm just going to wire in my primitives and my constraints. And I want to add just a tiny bit of drag, and I want to add a collision ground plane. Nothing fancy, I just want something to collide against when I run this sim. Let's try running the simulation. Yeah, nothing super inspirational there. But let's say I mostly like where the simulation is going, but I want to modify a few things. Well, I can do this with MOPs edit. So I'm just going to go, let's just go all the way to the end here. This is only going to take a second to calculate because it's pretty simple. So here's my end state. And I'm going to go ahead and just, well, before I do MOPs edit, again, MOPs really prefers you to have an ID attribute on everything. And we don't have an ID attribute right now. So really quick, I'm just going to use the enumerate SOP on my packed primitives. I'm going to set this to points and then this to ID. And now I've got an ID attribute unique for each chunk here. And now I can use the rest of MOPs without a hitch. So here's MOPs edit. And let's say I just want to adjust the positions of a few of these guys. Maybe I want this chunk to go. I'm going to press M to set this to world space. And then I want this guy to be slid over maybe a little bit more here. And maybe I want this chunk to be a little bit further away too. Nothing crazy. I just, I need things to land in very specific spaces. So I made my edits here. And now what I want to do is apply these back to the main simulation at a specific time. So to get the transforms from these points after the simulation, I'm going to use MOPs extract attributes. And I'm just going to, what this is going to do is basically just grab the template point attributes of all of these modified pieces, including these updates that we've made. And then what I can do is use apply attributes to apply them back to what came out of the simulation. The problem is that, as you can see, I moved a couple of these pieces, and I want to blend this in over time, right? I don't want these pieces to always be in that final configuration with that offset I applied. I want to sort of apply that over time. And so what I can do is gradually blend that in using a fall off, because apply attributes, right now, the fall off is just defaulting to 1, which means apply this all the time. And if I don't want that, I can just apply a fall off and that'll blend it in. You can see if I do a MOPs plane fall off on the incoming points here, and then I'll go to my end state. If I set this fall off value to 0, you can see that those pieces move back to their original position. Now they're at 1. So what I can do is for one or both of these points, because I could do separate fall offs for each piece if I needed to, I'm going to start blending in around here somewhere. So let's set this fall off to, let's see what the impact, somewhere around here, key that. And then at a certain point in the sim, let's say right around here, I'll key them here. So now when they land, those pieces slide into the position that I want. And you can't really tell, if you looked at it really carefully, you would notice that, oh, maybe these things are sliding a bit. But MOPs edit is letting me just really quickly dress up and tweak an RBD sim without having to think about it too hard, because RBDs are packed primitives. And then I can use the rest of MOPs to just sort of blend these things in over time. If I needed to do each piece individually, I could just do a chain of these plane fall-offs with different group settings, or I could use a shape fall-off if I wanted to be fancier about it. It's entirely up to you. But this is just to show that, you can use MOPs edit for a lot of things outside of motion graphics. You can tweak anything that uses packed primitives, and you can do it really quickly, and then blend the result in with whatever you already had using the rest of the MOPs toolset. Okay, now let's talk about MOPs physics edit. This node is a little bit more complicated, and then it has a few more controls that you have to worry about, but for the most part, it's pretty intuitive, and you'll pick it up really fast. I'm going to drop down a geometry container, and then make the usual Paul geometry, and then a MOPs instancer. We'll wire this in, and then let's just set the global transform to 0.2 so I get my little grid of Pauls here. Looks good. And then let's just go right to physics edit. So with this wired up, just like with regular MOPs edit, all I have to do is just point to the viewport and hit enter to activate the node state. You're going to see a selection handle, and you're also going to see your timeline shifts. And as soon as I start clicking on something, you're going to see that the timeline starts playing. The reason for this is that MOPs physics edit is basically a quasi-static bullet solver. You can think of it a little bit like the vellum brush tool in that it's running a solver actively while you're interacting with it. So if I just grab this handle and start moving Paul here, I can just rotate him and then just start dragging this around, you can see that any other geometry in here will get knocked around by him. I can select multiple Pauls and move them all around. Another thing to look for is if I select this guy and then either press M or hit this checkbox, I can switch between local and world space. So now you can see that Z is forward when I move him. I can move him in his own local space, or I can hit M again, go back to world, do the same thing here. I can also, just like with regular edit, I can select multiple guys here and rotate them all at once, or press Y to shift the handle, and then I can scale them up. And as I scale them, you can see they are going to displace the other guys. So it's pretty powerful. You can use this to make realistic piles of things, or just kind of knock things around in organic matter. It's good for set dressing. Once I'm done moving things around, you can see that if I just deselect something, the timeline will reset and go back to 1 and everything will stop. So I select this guy, timeline's running, turn it off, it goes back. If I exit the state, just like with MOPs edit, it's going to commit it and then return your timeline to back to where it was. And now you just have this new static state, this new little group of Pauls here. Okay, I'm going to hit the reset button to bring it back to its default state here, and then let's talk about a few of these controls. So first of all, this first thing you see besides the group is the pivot type, and this can either be local pivots or global pivot. What this means is that if let's enter the state, if I select all these guys, and I'm using local pivots, and let's say I scale them up. I'm going to hit Y to get my scale tool and then scale it. You're going to see that each one of these guys is scaling individually. They're trying to maintain their own positions here, but they're all scaling up. Let's click off of that. If I switch this to global pivots and do the same thing, so I'm just going to grab these guys and then scale up or down. What this is doing is basically scaling them all as if they were parented to the center of all of the geometry. So if I make this selection here and then scale up or down, it's all going to scale sort of relative to the centroid of all the geometry that you have selected at once, as if it was under a parent. But if I switch this to local, everybody is going to be scaled according to their own local pivot. Next, I want to mention some of these other controls down here. Let's start with the constraints. So the linear and angular constraint are basically how tightly your selected object is coupled to the handle here. So you can see that when I drag around, there's a little bit of lag, but not much. And that's because the constraint values are pretty high. If I tighten these up, you can see that he's going to follow much more rigidly to the cursor. There's going to be less bounce when I stop. So the higher these numbers are, the linear constraint is how tightly his position is tracked to my cursor, and the angular constraint is the same but for rotation. If I were to drop this to something much lower and then rotate him, you can see that there's a little bit of lag. He's going to kind of slow down a bit. The reason you might want to tune this is if you're at a very big or small scale. Sometimes that can affect how Bullet reacts to these things. Or if you're dealing with a simulation where things are really tightly packed and have low tolerance, you need to solve collisions in a very careful way. Sometimes it helps to lower the constraint values a bit to prevent nasty physics bugs from happening. But in general, the defaults are pretty good. And if it feels too loose, you can just tighten these, you can increase these numbers to tighten those things up. The linear and angular drag is basically the same principle, but what's applied to the other guys in the simulation. So if I turn these values up quite a bit, and then I'm just going to select this one here and move him around. Let's increase his drag considerably here. You can see that the other guys here are going to stop moving much more quickly. So again, before they were kind of slowly floating out of the way, and now they're just barely getting knocked around when I change the value. If I were to change these values and make them much lower, then when I select this guy and move him around, you're going to see that if I make a collision, they're going to float a much longer distance before stopping. So that affects mostly the guys that are not being dragged around, and the linear and angular constraints are for the guy that is being dragged around. Next, let's talk about these three options here: do translate, do rotate, do scale. These are a little fussy. There's limited utility for these, but the scale especially becomes important when you're doing certain kinds of operations, and I'll explain that in a second. If you turn off any of these options, what it means is that the constrained object is no longer going to respond to that part of the handle. So for example, if I turn off do translate and then try to translate this guy, nothing is going to happen. If I rotate him, for example, and he collides against something, you can see that he's actually going to slide a bit because his translation isn't actually constrained to the handle. So that's what that does. And similarly with do rotate, if I turn this off and then grab one of these guys, I can move them around. Turn on do translate. There we go. I can move him around, but you can see that he's going to rotate because his rotation is no longer bound to the handle. So sometimes this can be useful if you're trying to get like more chaotic results, or if you're trying to just have the guy that you're dragging also sort of respond and get knocked around in a believable way. But that's what those two toggles do. And do scale is the same. The interesting part about do scale, it's easier if I just show you how this works. I'm going to activate the handle. And then I'm going to select, let's say, half of these guys, and then I'm going to turn off do scale, and I'm going to enable global pivots. What this means is that if I were to switch to the scale handle while the sim is running, and I scale them, because do scale is deactivated, these guys aren't actually going to scale down, but the point positions are going to change. They're going to scale up or down based on how I move the handles. So this is really useful for bunching things up or spreading them out. I can grab all these guys and then wrench them into a little pile here, and they'll still be colliding. Same for this guy's here. I can just grab this, scale them up, scale them down. So do scale is unique in this regard in that you can use it a lot more practically for creating piles and bunches of things or for spreading them out. So keep this in mind when you're trying to do set dressing. The do scale is the toggle you'll probably use the most of these three. In the next tab over in bullet options, you're going to see some familiar stuff if you've ever done a bullet sim before. The number of substeps is just roughly how accurate the simulation is going to be. If you're moving things really fast, sometimes more substeps can help you there, but for most situations, you're not going to need to change this. Collision padding comes in handy when you're dealing with something that's at a very large or very small scale. This is just sort of a buffer that's applied to the outside of each collision shell that if your scene scale is very, very small, you might need to decrease this or else objects will collide outside of their visible area. Compute center of mass is the one of these options that you'll be dealing with the most. What this does is, again, this is another thing that's easier to show you. By default, with this tool, if you grab a packed primitive, it's going to draw the handle at the pivot point. And in this case, the pivot point is between the feet. So if I rotate, he rotates around his feet, and this is exactly how you'd expect. The catch with this is that in bullet, generally speaking, objects want to pivot around their center of mass, because when you're knocking them around, their center of mass is going to be, for the most part, roughly at the centroid, and that's going to affect how they respond to forces when they get knocked around. You can see that this guy kind of wants to stand on his feet. A lot of them are sort of leaning forward from their foot positions. And while this is really convenient if you have very specific pivot points that you care about, it can be a little tricky to get physically realistic results. The way around this is by enabling compute center of mass. So now when I click on something, you can see that the center of mass is now drawn, or the pivot is now drawn at the center of mass. So when I select this guy and move him around, you can see he even shifted positions when I first selected him. Sometimes it's more dramatic than others. In this case, these other guys already have their pivots set up, so I don't need to worry about that behavior happening again. But now when I drag this guy around, you're going to see that these guys are sort of staying a little bit more steady. They're not pivoting forward on their toes. They're moving around in a slightly more believable way because their center of gravity is now, where bullet is computing that it should be. So the trade-off of this behavior is that the pivots are no longer at the feet. So if you're expecting to move these guys from between their toes, it's not going to work that way with compute center of mass enabled, but you will get slightly better physical responses from the other primitives. Okay, now let's talk about some other interesting stuff you can do with this tool. So you might have noticed there's two other inputs to the MOPs physics edit SOP. There's an input for proxy geometry, and there's an input for static colliders. Let's start with proxy geometry. I'm going to drop down a template body just so that I have a couple of different options here for what's going in Instancer, and then just wire this in. So now half of our geometry here is this test geometry instead of just Paul. I'm going to go into physics edit and hit reset to reload it from the cache. So if I just grabbed somebody and dragged them around, I'm going to have to zoom in for you to be able to see this clearly. If I drag this guy around, you might notice that the collisions are not particularly accurate. You can see that there's a bit of, he's colliding even though these things aren't exactly touching. Let me drag this guy back here, and you can see that even though the hand is not really touching this guy that accurately, like there's clearly not accurate collision geometry drawn around these guys. And that's because when you just pipe one of these objects in by default, just like with the rest of Bullet, what you're going to get is a convex hull drawn around the piece, and it's basically going to look like a sort of a brick with shrink wrapped around them. It's not very accurate. It also can potentially be much slower. Depending on the complexity of your geometry, you usually want to compute collision geometry that is more precise and a little bit more simplified ahead of time. I'm going to reset this. So the easy way for you to be able to do that is with MOPs collision geo. So if you haven't watched the video tutorial for MOPs collision geo already, I highly recommend that you do. It's a really useful node for setting up collision geometry for rigid body simulations. I'm going to take the output of the instancer wired in here and then put the display flag on. You can see that these guys kind of just turn into these chunks. This is not exactly the same geometry you get by default if you put it into a bullet sim, but you can see that each of these chunks are convex hulls, meaning there's no concave pieces that move inward. With these controls, what I can do is just turn the initial remesh triangle size down to get slightly more accurate geometry from the get-go. I'm going to drag it down to maybe here somewhere. Now you can see I'm starting to get arms. I'm starting to get legs. Things like this are starting to get defined. And then I'm also going to drag down the max concavity, and this is going to help build slightly more accurate geometry. This is not great, but it's already a lot better than I was getting, and I can continue to drag these numbers down to refine this if I need to. The trade-off is that I'll get more pieces and it can potentially be slower, but now I'm getting something that actually resembles the bodies that I'm simulating. So once I have this looking the way that I want it to, all I need to do is wire the result of this directly into input 2 here on the proxy. And now if I activate MOPs Physics Edit again, you're not going to see this geometry again, but under the hood, it's using that proxy geometry for the simulation and then applying it to these as you move them. So now if I grab the handle again and start moving this guy around, it might not be obvious in this case, but in different, more complicated geometries, you would know right away. So now I'm actually getting hand-to-hand contact that's a little bit more precise. I can, rotate this guy and he'll collide more accurately with the feet than he was before. Just move this guy around. So like all of these little concave bits, like you'd actually be able to move the arms underneath each other and link them together. Things that you wouldn't be able to do with the default convex hull geometry. So just keep this in mind if you have a lot of these different guys that are sort of complex shapes, things that aren't easily described by convex hulls. Use MOPs collision geo and just wire it into the second input, and you'll get much better results and potentially faster results. Okay, for my last trick, I'm going to show you a more complicated example that also shows you how to use collision geometry. So the third input to MOPs Physics Edit allows you to input static collision geometry so that your objects can collide against something as they're moving around. Under physics options, in addition to having, you have a ground plane option, you have gravity, you have things like this that you can activate in order to make the simulation behave more like a typical bullet simulation so that objects that you're not actively manipulating will be affected by gravity and will fall over on things. Usually you'll want a ground plane when that's active, but also in 90% of situations, your ground isn't going to be completely flat. You're going to have other objects in the scene, and for that, you're going to want static colliders. So what I've done here is I've got a group of pig heads here, and I've already run these guys through MOPs collision geo, so they have a simplified proxy geometry to collide with. And what I've also done here is I've created a pretty dense grid, run it through a mountain, and then used extrude volume to turn it into a solid mass. So this is going to be my collision geometry. The next step is to run this through MOPs convert, and the reason that I'm doing this is that MOPs collision geo expects the input to be packed primitives. You could also run this through the convex decomposition SOP yourself, but this is already just sort of set up to go. It means that it's going to get a unique name attribute and everything else, a unique ID. So it's just, this is how I prefer to work within the MOP system, but as always, there's a number of different ways that you could approach this in Houdini. The next step is to run this through MOPs collision geo, and what this is doing is using convex decomposition to break this big, complicated geometry into a bunch of convex hulls that Bullet's going to have a much easier time reading. So this is going to make collisions more accurate and more and faster than they would be had you not done this, or had you used some other method. There's a lot of different ways that you can break down a geometry like this, but convex decomposition is one of the best. Anyways, now I've got this all laid out as one big chunky segment, and I can just plug that directly into the static colliders input. As long as the input here is all packed up like this, you really don't need to do anything else. Now I go to MOPs Physics Edit, and again, I have gravity and the ground plane enabled, so if any of these guys get knocked off of this geometry, they'll still have something to collide with once gravity's active. I'm just going to reset this to make sure everything is at the starting point. And now if I hit enter to activate the bullet sim, it's going to take a second to calculate. As soon as I grab the first primitive, the sim's going to start, and these guys are going to start settling in. So I can take this guy, scale him way up. I'm sorry, I've got global pivot enabled and scale is disabled. Let's turn that off, turn on local pivots. So now I can scale this guy up and then drag him down. You can see that even he is actually colliding against the ground, so I can't drag him through the static colliders. He's going to jitter if I do. And if that happens, don't worry too much about it. As soon as I let this guy go, he's going to relax. So I can use this to kind of bang these guys around, just use the pig head as a shovel. And all these other guys are going to settle in and collide with the geometry like you'd expect. And as soon as I let this guy go and select somebody else, he's going to settle in. And just select again, select nothing to stop the sim. Maybe I want to grab this guy. I can use him, move him around. Maybe I want him in a different place, and then select a different guy and he'll settle in. And then again, deselect to stop the simulation. Now, just to show you this trick one more time, if I have this collision mesh set up, I have all these objects that I want to bang around, and I want to kind of form them into believable piles. So I can select this guy. Everybody else will just sort of settle into place. I can grab a bunch of these guys, just select all these heads, switch to global, turn off do scale, activate the scale handle, and then scrunch these up. Maybe move them up and around these other pig heads, and then just select something else to drop them down, and they're all going to settle into a pretty believable pile and collide with this collision geometry underneath. So maybe I want to take some of these other guys under here, and I can rotate them in place. Or sorry, this is going to rotate them around a pivot because I still have global pivots enabled, but I can create like a really big chaotic mess. I can move these guys all over the place and just like make more selections, pick these guys up, and then let them go. And once these pig heads are settled down, I have this big organic looking mess of things that are all sitting on the collision geometry, and none of them are interpenetrating. So this is a really great way between the collision geometry and this trick with do scale and global pivot. It's a really quick way to get big messes of things that look a lot more organically placed than if you were to go in here with, let's say, a scatter sop or just manually picking and placing things. It's a great way of getting, chaotic, natural-looking set dressing. Thanks for watching, and see you again soon.